what we're going to be doing now is we're going to be solving a reducible second order equation. So x, y, double, I'm going to start that over again. X, y, double prime plus 2y prime is equal to 12x squared. Now because y is missing, because we have no y term, so we have a y prime and a y double prime, but no y on its own. Because we don't have a y on its own, our substitution is actually incredibly simple. So v is equal to y prime, and v prime is equal to y double prime. So we're just going to plug that substitution in. So that means that x, we've got xv prime plus 2v is equal to 12x squared. From there, we're going to divide the whole equation by x, which brings us to v prime plus 2v by x is equal to 12x. So now that we have that, we're able to take our integrating factor, and our integrating factor in this case is equal to x squared. If you're not sure how I got that, please make sure you check out the video on solving linear first order differential equations. So we've got an integration factor of x squared. We're going to multiply that by the main function. So xv prime x squared plus 2vx is equal to 12x cubed. You'll notice we've got a product rule going on here, so x squared times v prime plus the derivative of x squared, which is 2x times v, is equal to 12x cubed. So I'm just going to make a real quick leap here and just show you that vx squared, so I've taken the integral of that left-hand side, is equal to the integral of 12x cubed dx, which is equal to 3x to the 4 plus, I'm going to have to write that over here because my machine is conspiring against me, c. So I'm going to rewrite that just for simplicity, because it's so cramped over there, is equal to 3x to the 4 plus, that's c. So let's simplify for v here. So that we're going to make v is equal to 3x squared plus c over x to the 2. And one thing we should actually do here is make this a c1. And I'm going to get to that. So that's actually just a c1 there. So we know that v is actually equal to y prime. So we have to integrate this again. So that's why we actually had that 1 on that c, to indicate that that c1 came from the first integration. So there'll be a second integration with that c2. Now this should actually be, I'm taking a look at this now, and this should actually be, that's actually correct. I was mistaken. So we know that that's y prime on the right hand side here, so which means to solve for y on its own, we just need to take the integral of this function right here, which we'll do. So that becomes x squared, that one's pretty straightforward, plus c1 over x. And that should technically, when you make that integrate this function, it should become negative, but because c1's an arbitrary constant, we're just going to let that slide. So this should actually be an x cubed plus some c2 is equal to y. So again, that's why we had to make sure we included that 1, because when we integrated this, we're going to get another c constant, and just to show that we can't, those are actually two separate numbers, we're just going to pop those little subscripts on there. So that's how you solve a second order reducible linear equation. That's pretty easy to do. I'll try to make another video where I show what to do when x is missing, because that's a little more complicated, but not by much. So I'll see you on the next video.